Alright, let's go ahead and get started. I'm just going to start cruising through these early chapters. A lot of the work in the beginning is going to be book work. I kind of have to get through it in order to, I guess, get to some of the more fun stuff. I'm going to try and mix in at least a couple of observations about what's important in these different aspects so you can actually enjoy them. But we do need to go through the book work. There's a lot about the process and the software engineering in general that is actually necessary in order for our masters. So real quickly, we're going to do a software test analysis or analysis test in a quick nutshell. Alright, that's nice. So engineering process, we need to talk about a lot of different tools, and hopefully those of you who have worked out there in the workforce can tell that there is always a process, and the process, hopefully most of you all can see, is there for a reason. It's there to try and keep everyone aligned in what's going on so everyone can communicate with one another. Obviously, in a lot of businesses, the process has become way too big and needs to be streamlined. Unfortunately, that is mainly a manager problem, but there is some things you can do to help alleviate the bloat of the bureaucracy that has occurred. So yeah, just like in other engineering process, software engineering is the same thing. You still have to do construction and verification. You're building a bridge, you need to make sure it works. Software engineering, you're building a program, you need to make sure it works. So they take various forms, and the big thing I think to get from here is what exactly is verification. Hopefully you can pick this up from the book, but verification is making sure that the program does what you designed it to do. Verification does not mean you are ensuring that the program does what the customer wanted. It just means that when you designed something, verifying means that what you wrote actually works against your own design. So verification and design takes forms that usually go a lot hand in hand, but it's a very big engineering discipline and requires a final product and quality requirements. This is going to be the big thing I think most people new to this situation don't understand is what is the quality requirement. Alright, some characteristics that make that's verification and validation particularly difficult. So you have a lot of different quality requirements. You know, we want it to be good, we want it to look nice, or we want it to have be able to take a large load. I mean, hold on, well, what is all these things? So here's an example. An elevator can safely carry 1,000 kilograms. It can also carry a smaller load. If procedure correctly sorts a set, smaller load. So those are inherent. If procedure correctly sorts a set of 256, it may also fail at 255 or 53 or 12, as well as 257 or 1,024. The point here is you don't always know which way to assume. Because obviously with an elevator, if you can do 1,000, all right, it probably can do less, unless it if you don't load it up, it's like flies through the ceiling or something crazy. But you may have the problems where you can sort a certain number of elements, but not others. So we have to come up with a way to figure out how to test these correctly. So as we advance with technology, and a lot of different software tools out there, we try to reduce the errors, and this is very good with different software testing, but we cannot eliminate any errors. Now right now you're just going to have to accept me on can't eliminate this. In the next presentation I'm going to talk about the halting problem, which will explain why that is absolutely 100% correct. The other problem here is new development can introduce new kinds of faults, so if you decide to go to a distributed system, maybe you now have deadlock or race conditions. Other problems due to use of polymorphism or other dynamic binding that happens with object-oriented programming can cause some issues. And of course, private state and OOP can definitely cause issues, especially if you're doing something with reflection that allows you to actually inspect the internals of an object, which is not a good thing. There are a variety of approaches here. The big thing here to understand is when you apply testing, there is no fixed recipe. We cannot just hand you this is how you do testing and you call it a day and everything's good. Unfortunately, that's not how it works. I mean, if it was how it works, we'd probably write a program that does this for you, but it's not how it works. Test designers, they have to choose and schedule the right blend for the system. So you want to reach the required level of quality. And what do I mean by quality here? Well, let's say if you have an app for a phone, and you have a program making sure someone's heart keeps beating. Of the two, which one needs to work? Well, obviously the heart one needs to work way more than the app. So that means that the testing for the, I'll just call it the heart app, or the heart program, the life support, how about that, is going to require a higher quality, which means it needs more testing. Hence why it usually costs a lot more than an app on your phone. It's because they've thoroughly tested it to take care of a lot of different corner cases. So first we need to require quality. We also want to stay within the cost constraints. You're probably not going to pay for a phone app what someone would pay for a life support system. You need to design a specific solution that suits, of course, your problem requirements and the environment. Okay, it's just a phone, or hey, it's going to be living in a hospital, and now we need to make sure we abide by HIPAA's requirements. Here's some great questions. I wish I could just ask you these and see what comes out, but it's online, so we're going to go through these. When does verification and validation start? Well, if anyone asks you when it should start, pretty much the answer is now or in the past. When are they complete? Actually, usually that's never, but this time there is actually a set point when they're complete. What particular techniques should be applied during development? We'll go into a couple of those. How can we assess the readiness of a product? Ooh, that's a great question. Hopefully you can tell by a testing suite. How can we control the quality of successive releases? That's what's called regression testing, where we have a battery of old tests to make sure no new problems have arisen. And how can the development process itself be improved? We'll go into that as well. When does verification and validation start? As opposed to what a lot of the models test, it's not supposed to be late in the phase. You really should be thinking of testing in the beginning. While you may not be writing test cases in the beginning, although you should, you can really save some time by integrating some test hooks or some test frameworks in your code when you start coding it up. So you really want to start thinking about it as soon as we decide to build a software product, sometimes even before. And it can last far beyond the delivery, especially with maintenance. So we have to revalidate it every maintenance, and this is very common in the military. Or actually, it's very common in the military to try and avoid the full validation, but you still have to do some validation. Officially, and this is just to give you some terms, you do want to conduct a feasibility study. A lot of times you might think of this as analysis of alternatives, but you want to first figure out, is this actually possible? Can we actually write a program that drives a robot to build a bridge? Well, that might be a little hard. Or can we write a program, an app that keeps track of, the eclipse that's supposed to happen today? All right, that's definitely something that can happen. So we have to do analysis of the risk, and that's a huge, huge deal on the business side, is they always want to know what the risk is. They understand that most of them understand from an engineering standpoint that nothing's guaranteed, but if they can manage the risk effectively, that's what they're most important, or what they want to look at the most. Even if you just say low risk, medium risk, high risk, that helps them tremendously. So yeah, it goes on beyond maintenance, a lot of times with fault tracking and analysis. All right, so what technique should we use? First off, no single analysis and testing technique can serve all purposes, but you need to figure out the effectiveness, how applicable they are, the differences, and the trade-offs as well. These are just different examples. You also need to make sure you integrate with their Gantt chart. If y'all haven't seen this before, the idea is that time starts here and it moves forward, and you want to kind of think about what overlaps with what. Notice that you got to identify, plan the acceptance test, plan the system test, then you validate the specifications, or verify it is actually the correct word. Do analysis of the design, spec the design. Notice you can also generate a system test, so forth and so on, moving on, until you're finally finished with actually updating the regression test and finding all the faults and improving maybe your process. So how can we assess it? Well, analysis testing during development aim to reveal the faults. We can't reveal or remove all faults. Very important. Again, the next slides with a halting problem will explain this thoroughly. Hopefully, we'll make you understand this thoroughly. Cannot last indefinitely because we have to deliver something at some point. So we have to basically specify what is the required level of dependability here and determine when we've attained it. All right, there's different ways to measure it. you can have the mean time between failures. So when your program fails, because we're just going to assume that it has to at some point. I know it's starting off negative, but you just have to do it this way. How long is it going to go between it failing again? And that's actually a pretty important metric, because it indicates the fraction of all attempted operations that can complete successfully. Because if your mean time between failure is a minute, that means you have a minute to accomplish all your tasks. Probably not too much time for certain systems. Mean time between failure is a month or two. You probably have at least some time to get everything done. Let's see. So you got 50 interactions for credit cards. The software always operates flawlessly up to the point that the credit card is being charged, but on the half that attempts to charge the wrong amount. What's the reliability of the system? Well, there we go. If we count the fraction of individual interactions that are correctly carried out, only one operation 100 fail. The system is technically 99% reliable. If we count the entire session, only 50% reliable, since half the sessions result in an incorrect credit card charge. Hopefully that makes some sense what's going on. Assessing dependability, so you can randomly generate the test. You do an alpha test. Normally those are performed first, and then of course beta, hence alpha beta. But usually beta is done by the real users. Really what's going on in alpha is your verification. You're verifying that your design is accurate, and then beta, you're having users actually validate the design. How can we control the quality? Well, yeah, so it doesn't stop at the first release. You have to keep going as time moves on. Quality tasks after delivery, make sure you're testing out. You do actually test your new modified code, and go ahead and re-execute all your tests, aka regression test. Now, how can it be improved? This one might be a little hard to understand why we're talking about it. What I'm talking about here, a lot of times from the technical side, you're going to see the same defect coming up over and over and over again. So what you want to do is be able to identify why is this defect coming up? Why is a coder always coming up with this defect and putting it in their code? Is there something we can add, something easy we can add to the process that will aid the coder in not falling for the same trap over and over again? So you want to identify and remove the weaknesses in test and analysis to remain undetected. All right, 4-step process: improve fault analysis and process, define the data to be collected, analyze it, select fault classes, and then adjust the quality development process. This is a process level. This isn't actually technical level. So it's kind of helping the business person out by collecting all the procedures and then doing the analysis for them and then presenting it to them. This is really your argument of how to either streamline, aka make the process simpler by eliminating a bunch of stuff and saying, look, we just need to have a bigger regression test called a day. Or you're saying, okay, look, we're going to have more code reviews, which is another added process and bureaucracy, but sometimes, unfortunately, that's the way it is. All right, here, okay, good. We got an example. Faults that affect the security were given highest priority. During analysis tests, we identified several buffer overflow problems. Faults were due to bad programming practice, were revealed late due to a lack of analysis. So we can modify programming discipline and environment to add specific entries to inspections and checklists. Okay, we could have a code review at certain points before you submit the code. This is actually very common. And when you submit a code, someone else has to verify it, that it actually makes sense. Usually it's the owner of the code, just to make sure that your code goes in and is not going to break anything. All right, so we have 3 main goals: improving software product assessing. We have to combine all of these throughout the software process. Analysis testing depends on organization and application domain notes. It's very specific for every domain. Cost effectiveness depends on the extent to which it can be applied. All right, so look guys, this is just a high-level view. Keep in mind that with testing, while there's a lot of technical details that we are going to get into, got to keep in the back of your mind that we must always be able to integrate into the process, because there's always a process that needs to be followed, because when it comes down to it, your manager only understands the process. He really doesn't understand too much of what programming is. You start even talking about it even a little and they have no clue. So always keep in the back of your mind, how are we integrating in the process? How are we making sure everyone is on task and helping and aiding and improving the software quality of the code so we can meet our goals? All right, and that's it for this one. Next will come the halting problem.